Okay, imagine this. A time long before any stars existed. Before galaxies even formed, the universe was just, well, dark and quiet. What if we could actually eavesdrop on that moment? What could we learn? Today, we're doing a deep dive into something called CosmoCube, whispers from the cosmic dawn.
Mhm. Now, you've shared some really fascinating sources on this, and our mission basically is to unpack how this tiny satellite aims to hear an ancient whisper from the universe's very beginning. We want to figure out what it might tell us about the universe's dark ages and the cosmic dawn that followed, and why this quiet little mission could actually be a huge deal for understanding, well, everything. I mean, trying to hear a whisper from billions of years ago, that sounds almost impossible, doesn't it?
It really does. And that's what's so fascinating here, the sheer ingenuity needed. Because the biggest hurdle isn't just the faintness of the signal, it's the noise. The noise from our own planet. Overcoming that is the real challenge. Right, the noise. Before we even get to listening, we need to picture this era they're targeting, the Dark Ages. Can you maybe paint a picture of that? What does that mean?
Sure. So this is the universe in its infancy, really, just after the Big Bang cooled down a bit. But crucially, before any stars or galaxies lit up. Space was dark, filled mainly with neutral hydrogen gas. It was simpler, more uniform.
And trying to study that from down here on Earth is, well, incredibly difficult.
Oh, immensely difficult. There's that great analogy from Dr. Eloy de Lara Acedo. It's like trying to hear that whisper while a loud concert is playing next door. Earth is just buzzing. Atmospheric disturbances, TV broadcasts, radio, all our electronics. It creates this overwhelming radio noise.
Yeah, just think about that for a second, you listening now. All the technology around us, the Wi-Fi, phones, radio stations, it's a constant hum, or really a roar. And trying to pick out the faintest possible signal from the dawn of time through all that, it really makes you appreciate how much our own tech gets in the way of seeing or hearing the universe.
Exactly. So the clever solution, get away from the concert. The CosmoCube mission plans to orbit the far side of the moon.
Ah, okay. So not just going to the moon, but specifically the far side.
Precisely. The moon itself acts as this huge natural shield. It physically blocks all that radio chatter coming from Earth. It creates a uniquely quiet environment.
So the moon becomes part of the instrument, in a way, creating this cone of silence.
You could say that, yeah. And CosmoCube itself, the satellite, it's designed to be small, relatively affordable, too, using a CubeSat platform. But it's equipped with this very specialized instrument, a finely calibrated low-power radiometer.
Yeah.
Think of it as a super-sensitive ear.
Okay.
And it's tuned specifically for those very weak signals operating at low frequencies, like 10 to 100 megahertz. That's the range where we expect this ancient signal to be.
So going back to that concert analogy, moving to the moon's far side is like finding a soundproof room to finally hear that faint whisper.
That's a good way to put it. And connecting this to the bigger picture, it's more than just finding a quiet spot. It's about using this natural shield, the moon, to open a completely new window onto the early universe. It's about creating the conditions needed to finally detect signals that have been completely inaccessible until now.
Okay, so I've got the quiet location. What exactly is this whisper? What's the signal they're actually hoping to detect? It's not just background noise, is it?
No, definitely not. It's very specific. CosmoCube is designed to pick up a particular radio signature from neutral hydrogen. Hydrogen was the first, the simplest and most abundant element in the early universe.
Right.
So this signal, this ancient whisper, is effectively an echo from that hydrogen from a time before stars even existed. It's a direct probe of that era.
Wow. Okay, so listening to the universe's first hydrogen, and what can that tell us? What secrets are locked in that signal?
Well, potentially. A huge amount. It could hold clues about how everything began, like the very initial conditions. And maybe more importantly, how structures like galaxies eventually started to form out of that initial smooth state.
Oh, okay.
As Dr. de Lara Acedo put it, it's about understanding how the universe went from being simple, dark, and uniform to the complex, light-filled cosmos we see today, full of stars and galaxies. It's like listening to the first hints of cosmic structure taking shape.
That's really profound, listening to the literal building blocks hydrogen and using their faint signals to figure out how galaxies emerged. Professor David Bacon said something like, "It's incredible how far these radio waves have traveled, now arriving with news from the universe's childhood."
Exactly. And this Dark Ages period, it really is one of the last big unexplored frontiers in cosmology. We know very little about it directly.
So what else could this news tell us? Beyond just the formation of the first stars and galaxies, does it connect to other cosmic mysteries?
Oh, definitely. One major area is dark matter. CosmoCube's data could give us unprecedented insights into this mysterious stuff. How it behaved in the early universe, how it interacted with the normal matter, the hydrogen, basically how it shaped the cosmic web we see today. It could shed light on dark matter-baryon interactions.
Okay, so insights into dark matter. That's huge. And you mentioned it might tackle another big puzzle in cosmology today.
That's right. One of the key goals is to shed light on the Hubble tension.
Ah, yes. This disagreement about how fast the universe is expanding.
Exactly. There's this persistent mismatch between the expansion rate we measure from the early universe, like from the cosmic microwave background, and the rate we measure using objects closer to us more recently in cosmic time.
And CosmoCube could help resolve this.
Well, that's the hope. By providing this pristine view of how structures first formed, which is deeply linked to the expansion history and the cosmological parameters, it might give us a new independent measurement from a crucial era. If it helps reconcile the tension, or even if it confirms the discrepancy with high precision from this early time, it could force us to rethink our standard cosmological model.
Wow. So potentially rewriting cosmology textbooks.
Potentially, yes.
Yeah.
And beyond that, the data will just generally deepen our understanding of fundamental physics in the extreme conditions of the very early universe.
This isn't just a concept on paper, though, is it? This mission is actually moving forward.
Absolutely. It's a real project. CosmoCube is led by the UK, but it's an international consortium. You've got researchers from Cambridge, Portsmouth, SCFC, RAL Space involved.
Okay.
It's backed by the UK Space Agency's Science Bilateral Program, and they're working with industry partners, too, like SSTL Ltd, who are building the actual satellite platform.
And how far along are they? Is this still years away from being a reality?
Well, instrument development is well underway. They have working prototypes in the lab. They're doing environmental testing, things like thermal vacuum tests at the RAL space facilities to make sure the hardware can survive up there.
Right, the harsh environment near the moon.
Exactly. The timeline they're aiming for is about a 4 to 5 year roadmap to launch.
Okay, so relatively soon, in space mission terms.
Yeah, the goal is to be in lunar orbit before the end of the decade.
They just presented the proposal recently, actually, at the National Astronomy meeting in Durham.
So you, listening, you could genuinely be hearing about the first results from CosmoCube, maybe revealing secrets from the dark ages before 2030. That's pretty exciting. Okay, let's sort of pull this together then. We've talked about CosmoCube, this small satellite with a big ambition, heading to the far side of the moon, using the moon itself as a shield to escape Earth's noise. Its goal: to listen for these incredibly faint radio whispers from hydrogen dating back to the universe's dark ages, before the first stars.
And this data could unlock secrets about how the first structures formed, maybe give us clues about dark matter, and potentially even help solve the Hubble tension.
It's really about pushing into an unexplored epoch, finding that quiet place needed to hear the universe's earliest stories.
It really makes you think, doesn't it? Consider this. If we can send a tiny box to the far side of the moon to listen for the universe's first sounds, what other incredible stories are out there just waiting for us to find the right way, or maybe just the right quiet place to listen?